So my name is Rene Neumann. I'm the Director of Solution Engineering. I'm working together with Karush, and I want to welcome you all to our Tech Field Day event 26. So over the next few minutes, I want to explore with you the different building blocks. And as part of each building block, I'm going to show you a little bit our product. So we're going to make it a little bit more interactive. You will see what we are doing, how the product looks like, and exactly what we mean for every single building block. So we are going to switch a little bit forth and back between the presentations. Just a quick recap. So the blueprint has essentially four main blocks. So you have at the top the AI ops and the orchestration and automation. That is really where you have your traditional automation and AI tools like your Cisco DNA Center, your Blueware, your StackStorm, or the simpler automation tools, your Ansibles, your Puppets, your SaltStack, or anything like it, right? But really what those solutions typically imply is that there is a connection path to your infrastructure, to the infrastructure you want to drive the automation to. Now, that is a little bit the nice weather scenario, because we all know that connection is probably mostly there, but not all the time there. And the second challenge with that is if you skip over the fact that how do I get my automation to actually talk in a consistent and resilient way to my infrastructure, is you leave the customer a little bit open to decide which way to implement it. And sometimes customers are not 100% sure. They want to have a solution which scales out over the next 5 years, will grow together with them. So there isn't necessarily an easy starting point. There's a little bit of anxiety around, as Karush mentioned, that the automation might impact day-to-day operations, and then I need to manually fix it. I need to manually revert what my automation has done. So the loss of control is a big fear, which prevents actually many customers, which I'm talking to, from even starting on the automation journey. And the last big one is, if you want to do it right, then there are multiple pieces which you need to put together. And if you haven't done any automation at all, then that might be a little bit overwhelming to learn all of these different tools and figuring out how do they actually work all together. So that is where the blueprint really comes in, and that is what we recognize as part of the owner group. When I was there, is all of these building blocks, they're not new. They are most enterprise customers already today have most of these building blocks in some shape or form in their environment. We just put them together in a more concise way. So the automation infrastructure really acts as a glue between the higher layers and the lower layers. So they combine the two. They build that entire infrastructure. And the automation infrastructure, the building blocks are really the tools which must be deployed in pretty much any environment if you want to be successful with automation in some shape or form. So in total, there are 7 building blocks which we're going to look at. We have the out-of-band management in itself. We have the resilient and secure out-of-band part, which Karush termed so nicely our rings of power. Then we have the tools, which are really important. That would be typically a jump box, for example, for would be familiar with those. Then your visibility and observability tools, your edge native automation, we're going to look at that, and the version control and source from controls. I'm not going to cover those in detail, so we're going to focus on the first 5. So then let me briefly cover the environment which I'm going to use for my demo. All the demos which you're going to see is the same environment. I have a FortiGate firewall, small one, which is typically a branch deployment. And that is connected through a rack PDU so that we can turn it on and off, have some power control through it. And we have 2 connections to the FortiGate. We have a standard management network to the FortiGate as well as a console interface. We're going to use both. We have a temperature and humidity sensor for the environment just to control and see what is actually happening in the environment in itself. And then we have two dedicated out-of-band WAN connections. We have an LTE connection and we have a VDSL connection terminated on the Node Grid NetSR, which is our modular appliance. And through those out-of-band connections, we have secure tunnel in form of an overlay network using zero tier to an AWS VPC instance. In the VPC instance, I'm using as my poison of choice Ansible for the automation and Netbox as my source of truth. So we're going to interact mostly with those. Around Ansible, ultimately, Ansible only stands in here as one example for automation. You can use and choose whatever automation tool you want. It can be a commercial version, can be an open source version. It makes absolutely no difference. Then let me briefly cover what do we actually mean by out of band? Because I was already hearing that a little bit based on the earlier discussions. Really, it depends if you're in the IT space, in which area you are. In general, out of band means it's a communication by a channel which is not your primary channel. So what does that mean? It essentially means that you have a production network typically, or production communication channel, and you need to have a separate, ideally it needs to be a physically separated second channel, and that second channel is considered your out of band. Now, if you look at, for example, at Cisco or Juniper, they just talk about out of band access, and typically they mean a management network, what most people would just consider a management network. So it's a network interface where which you plug into your switch, but it's really required for ACI or even for Juniper, right? Intel would define exactly the same thing. If you go to VMware, they are talking about IPMI interfaces. If you talk to or look at storage vendors or anything like it, they all talk about out of band, but in a slightly different annotation. Because of that, for us, out of band means actually everything altogether unified. So we are talking about the traditional out of band, the low-level non-IP based access, like console connections, USB access, any of those. But we're talking about the management network as well. So we're talking about connections through IPMI, through traditional management networks like SSH, Telnet, Web UI, APIs, as well as power and environmental sensors. So all of that combined is for us out of band. So when we're talking about out of band management, then really that is your entire management network, as well as the non-IP based stuff, all combined. And that is the first building block. It's probably the most important one, where we define a physically separated environment from your production network, which drives your management access to all of your end devices. So that includes your servers like your Dells, HPs, your storage, your network equipment from Cisco, Juniper, Fortinet, Palo Alto, through standard IPMI interfaces, SSH, APIs, or Web UI, as just mentioned, or through serial standard USB serial connections, or even USB pass-through for mass storage or anything like it. And that is the combination of the out of band. And we can provide the connectivity to all of those interfaces in a single solution. So what you see is a Node Grid appliance. That is the NetSR, which I've seen in the environment screen. The actual unit is based in Ireland. So I'm presenting to you on the West Coast. I'm sitting in New York, and my demo setup is in Ireland. So we try to make it global today. And what you see here is typically the first screen, which all of our customers use when they utilize the out-of-band capability. We list out all the target devices which are configured here and connected to our device. And you can see a range of serial console devices. Like here's the serial console connection to a FortiGate device. We have here power control option as well through Rec PDU. I can just highlight that and get the current power status, for example. I could power cycle the device from here if I wanted to interact through the CO console port of the device. If I do it through the web UI, just a new window opens up, and then after a second or so, I'm connected to it, and now I can log in and interact with the device. But I can do the same thing for, as I mentioned, for IP-based interfaces. I have here the same Fortinet connected through SSH and through a web interface. So if I click on the web interface, then we act like a terminal server where the NetSR connects to the FortiGate, opens up the web interface, and forwards that screen to me. So very similar to Citrix terminal or something like it, where you jump onto a jump box and from there on. So here I can just log in and then interact with the web interface as I would have a direct connection. But as you can see now, I can just interact with the device and do everything what I need from here. I already mentioned a bit Rec PDUs. We support a wide range of Rec PDUs. That is, in this specific case, an APC power strip with 8 outlets. I have multiple devices connected in my small lab environment. So that is a power strip which controls the FortiGate. And what you've seen earlier on was actually I assigned only that one outlet number 4, to the FortiGate device. All of that gives me the traditional out-of-band break-fix access, so that if something is broken, I can easily connect to an end device. Further to that, then, typically what I want to know is maybe environmental details. As I mentioned, we have a temperature and humidity sensor. You can see here the current readings. I'm going to show you a little bit later as well as how you can get historic values, historic readings, and how you can use that to drive your automation, for example. If you have a serial connection or any text-based connection, really, then we offer a data log as well. That gives you a full history of what happened on the device, who logged in, when did they log in, what commands did they run, and what was the output from it. If you see here a lot of different commands, I use the device quite extensively for preparing for the demonstration. So you see every single time I logged in and the different commands I'm using and everything in the data log. Now you can use that data log then later again to drive your information, to drive, create events and drive those to your automation. And we're going to look at that in a little bit more detail. Really around the out of band, the last point which I really want to show you as a quick overview is you can already see that I can connect to IP-based devices. The NetSR is unique in that sense that it provides you with a combination of serial ports as well as a built-in switch. So actually all the network ports are available through an internal switch, which is a managed switch. So if you go to network connection switch, here you see all the current available network ports. You can configure them from here and interact with them as if you would from a layer 2 switch. So really for management purposes, we could fully replace an existing network switch which you have for the purpose of connecting management interfaces up to our device. And allowing you to collapse a stack. For example, in a top of rack scenario where you have a combination of serial connections, USB connections, as well as network connections, you could connect them all up to a single appliance and then run the appropriate network connectivity back to a more central location.
So the network switch on that, is there a router option too? So if you wanted to do L3 at top of rack?
Correct. So in the switch in itself, or the design, I would say it's probably a little bit unique in that sense. The switch in itself isn't really a layer 3 switch, so you wouldn't do any routing on the switch, but the switch is connected through the two backplanes directly to our node-grid OS. And on the node-grid OS, you can do auto routing. We have full routing capabilities like BGP, OSPF, and everything else. So you would use the two backplanes to pipe the traffic to our node-grid OS and then do the routing on our layer.
So I noticed that you can do a lot of automation to configure things, and you have audit trail logs. What is the capability of state drift? Does the ZPE system leverage those automation tools to determine if there's any state configuration drift?
I'm going to show that actually. It's actually one of my demos in a short while. Give me 1 second. Give me 2 more demos. And
okay,
then
I'll pause that thought. Thank you.
Okay, perfect. Then let's briefly go on to the next building block, and that is what Karush called his OB-WAN ring, really, essentially. So that is all around resilient and secure connectivity. So really, if you think about it, if we in your location create a physically separated environment to connect all your management interfaces, so essentially air gap your management interfaces, and then you want to do the same thing with your WAN connectivity because you need somehow a way in, a connection into your site. And that needs to be as secure as your production environment. There's absolutely no question about it, maybe even more secure. So that means we as the provider need to provide you with a wide range of different WAN connectivity options, including MPLS, 4G, 5G connectivity. But on top of that, you probably want to deploy a VPN solution like SSL VPN, IPsec. We support WireGuard as well to set everything up. We have our own SD-WAN solution, as Karush mentioned. If you just want press one button option, essentially, to deploy connectivity between all your different sites. But if you don't want to deploy our own SD-WAN, then you can as well, besides just standing up your normal VPN tunnels, you can create an overlay network using zero-tier Tailscale or any other overlay network providers which are out there by easily just installing their agents or their clients on our box and enable that connectivity. As I mentioned, actually that demo runs over zero-tier network. And on that network, there are currently only 3 hosts connected to. It's my laptop, that is a net, the Node-Grid NetSR, and it's the Ansible host, which I have in my AWS. Nothing else is running on that network. Okay, and everything what you see is actually running over that one network. So with all that capabilities, we provide you the cross connectivity between different data centers, to your cloud providers, to all of your different edge locations, be it a small office, be it an edge compute node somewhere, or just a small little interface somewhere along a smart city deployment, maybe below a camera, and to watch which parking spots are currently available somewhere. We already spoke briefly about the routing. We have FRR routing installed on our appliance, which is fully up to date. So all the capabilities which you have with FRR routing are available to you as a customer. Most customers use OSPF version 2 or version 3 or BGP in any shape or form. And the goal here again is to collapse, to enable you to collapse the stack. So instead of deploying 3 or 4 different devices, which provide maybe LTE, which provide MPLS, and then you have maybe an additional router behind it to combine all of these connectivities and provide a failover or anything like it, we can combine all of that in a single appliance. Perfect. So let me briefly show you that. As I mentioned before, on the WAN side, you configure the WAN connections and the network connections. Here in my case, I have on backplane 0, I have the standard WAN connectivity through my FortiGate. I have then my ETH0, which is connected to my dedicated VDSL connection for out-of-band purposes. And I have as a last option, as resort, I have an LTE connection as well. If I wanted to add in new WAN connections or new internal connections, I just would go to add and then select from the wide range of different connection types and then just configure the interface to my own personal needs. The failover in itself is configured under network settings, where you select what is your primary interface, and then you can set and define the appropriate rules when they should fail over. As you can see, we actually support up to 3 levels of failover. So I have my primary link on the FortiGate, then I fail over to my dedicated VDSL connection, and the last option is my LTE connection in my case. And depending on what the connection type is, you have different failover options. So if the secondary connection would be my LTE connection, then I would have different failover options to go to the third one, like what is my bandwidth utilization, what is the reachability, and so on and so forth. So depending on that, you have different options available to you.
And the reachability triggers, is that just like ping options, or can you do payload requests or actual transactions?
For the time being, we only really do a ping test here. Now, I have to say now, we are a platform, right? So if you and one of the bigger differences from us to many other vendors is ultimately you can utilize us in whatever shape you want. If you need an appliance, then we're going to be an appliance to you. If you log in, you get a CLI, you get a web UI. If you need more server style, we can give you full Linux access. We run our own stack of Linux, but if you want to deploy your own little script to do some payload checks or anything like it, absolutely no problem. Our SD-WAN actually has more capabilities for failover, natively built in, so that might be another option as well.
I just had one quick question. It's kind of like a side note. Like, do these devices in some way have like microphones integrated into them? Reason why I ask is I know someone asked a question in the past that if like the fans, like if the cooling units were starting to fail themselves and the fans were starting to kind of run higher, give you that like early detection to know like that hardware could be failing?
So far, no. I don't see a reason why we couldn't easily add a microphone to it. I mean, ultimately, it's just an additional sensor. We have actually a wide range of sensors already.
Yeah, Rene, the airflow sensor. So we actually have
we have an airflow sensor.
Yeah, 2 different types of speeds. So depending on if you want to actually measure cold or hot aisle or actually the fan behind the UPS.
Gotcha.
Those are 2 popular sensors.
Yeah, like something that'll kind of early alert you, just like you said. And I mean, it's not going to be like one massive loud sound, but just something has it slowly, like that whining starts to increase. You know, there could be potential hardware.
Right, the acoustic, but that's actually how UPS and FedEx detect ball bearing failures in their belt from like 15 years ago. But you're absolutely right. I think acoustically or fan speed. We also have dust sensors, so OSHA certified dust sensors, particulate sensors as well, that is already available for shipment.
Awesome.
Yeah. So we already have a wide range of different sensors. I guess the only one who's missing would be an acoustic one. Right. But as Kurush outlined, we have particle sensors, we have the airflow sensors, temperature, humidity sensors, dry contacts, and many others. So now let's jump on to the next one, and that is our tools section. So what do we mean by that? Now, in general, most enterprise customers require some form of remote IT presence in every single location. So that is typically realized through a jump box, which might have installed locally. And in most cases, those jump boxes provide some form of a file server capability so that you can maybe store a local backup, that you can serve file firmware updates out, or there are many other reasons why you might want to, at least for a while, store some form of a file and then serve it out to another source. Most jump boxes are either based on Windows or Linux. So we can provide a lot of that capability directly out of the box, but we provide you as well with the capability to actually spin up your own jump box server on our platform in form of a virtualized machine. We fully support containers, So if you just need a small one, then you can probably deploy a container, or you can fully deploy a full-grown VM like a Windows system or anything like it. Absolutely no problem. On those Windows systems, and then you can install whatever you need. We have some customers who have some form of SCADA control systems even locally running in case of a backup, or you can just install a wide range of Docker containers, as mentioned. Okay, so those tools are actually typically quite important in a remote location. The other thing which I want to mention here is the requirement to have these kind of jump boxes actually leads in many cases to the shadow IT, the deployment of your small little Raspberry Pis or NUCs. And typically what happens is they're just getting plugged in somewhere, tools are getting installed, and then they're being forgotten about it. And they're not getting patched, and there are no security updates there. Half of the companies probably don't even know where they are and who configured them. And that is a huge another source of risk which you expose a company to. So by providing those level of tools and capabilities as part of our appliance, we streamline that entire process and give at least the visibility and the control back to you as an organization. So a lot of those tools, as I mentioned, are already on our appliance in itself. Let me briefly show you actually what you can do in terms of file storage as first. So your typical file storage solutions we bring as part of our appliance. You can turn them on and off, like a TFTP server, like an FTP server. They are natively on the unit, but because we have a web server as well, you can use our own web server as a file repository. Now that's actually what I'm going to show you right now. That file repository works in a relatively straightforward way. We have a file manager, which is a graphic array, and you just upload your file to the data store. I already have done that earlier, but essentially if you needed to, you could just click on upload, browse your local PC, and then upload it to the data store. Or you just copy the file over via SCP or any other shape or form. Now, to get to the file, you just need to know the right URL, which is in this case the IP address of the node grid, data store, and then the file name. You can't browse the data store. That is one of the security options built in. So you need to know the exact file name. But as you can see, if that would be a configuration file and YAML file or something like that, I could directly serve that out to a target device as well. Okay, or it could be a firmware file as well for that matter. So we really make it easy to share files locally with your environments. And the second option is you can use our cloud. And actually, I forgot to show you something a little bit early on, which I'm going to do now, is we have our own cloud environment, which is a SaaS service. And that cloud environment allows you multiple things, actually. The very first one to round off the file service is our cloud offers a cloud storage, which we call extended storage. And that essentially allows you to upload files to our extended storage. And that extended storage is automatically shared with all appliances which are part of your organization. Okay, so you can see here already I have a couple of folders here, I have a couple of firmware files here. Just uploaded them a little bit earlier, like a FortiGate firewall, firmware, and a couple of other things. And those files are directly available on the end device as well. I'm just going to show it to you as part of the file manager. In the file manager, if I go to remote file system, extended storage, shared, and now I'm in the same folder structure as what you see here in this view. So I can go down to firmware, and I can see directly the same file. They are locally from the command line accessible as well, so I can just copy them to different locations. I can upload files exactly in the same way as well. So if I have a local file, I need to share that out with other systems or anything like it. It works in both directions. So it's really like a cloud storage for your out-of-band needs. Just to finish off, what I forgot a little bit to do a little bit earlier with our cloud is we spoke about the out-of-band and the WAN connectivity. One part which we offer through our ZPE cloud as well is full out-of-band access to your appliances. So in this case here in my Ireland location, I have that node grid connected here as well, and I can open up a web session or console session to the device. I could directly connect to an end device as well from here. So if I click on web, that will open up another window. The advantage of using our SaaS service is that there's absolutely no need to set up a VPN tunnel or anything like it. The node grids out of the factory will automatically connect to the cloud. You can claim them if they're yours into your own environment, and then you can directly access your devices using a secure TLS connection from your laptop going to the device. It's exactly the same interface as what I show you under normal circumstances.
How much granularity do you have with the cloud solution? So can I set it up where this set of users only has access to the FortiGates, but these ones have access to the switches and servers?
So the cloud in itself is designed really for administrators, but the device level access is controlled by the end device. And what I mean by that is essentially we enforce access and control always on the end device. That is not even controlled by the cloud. So as you just have seen a second ago, when I click on open up the console session, I still need to authenticate locally against the end device. So just because I have cloud access doesn't mean that I have access to the local end device.
So effectively you have view-only access, but you can't authenticate into the device? Like,
yes,
yeah,
because they are fully separate, yes. Right. And even locally on the device, I might have only read-only access or only access to one single device as well.
And then the options on that end device, is that like you have SSO options there as well that's centrally managed?
Yes, we have a centrally managed option as well. You can even control and manage our devices through our ZPE cloud, as well as we have an on-prem version as well where you can push configurations out to different devices. So all of that is possible.
So, specifically asking about the user credentials for those like the NodeGrid SR or NetSR devifully
Is there RBAC or
yes. So yes, fully understand. So we have multiple authentication servers. Locally, we support your standard ones: LDAP, Active Directory, Radius, TACACS, Kerberos. But we fully support single sign-on using Summit 2 as well. So if you have your Okta, your Ping ID, your Active Directory FS or anything like it, then you can use a single sign-on provider as well to log into the cloud as well as to the end device.
And they also support an MFA?
Yes, yes. So locally on the box, we are supporting multi-factor through RSA tokens, and then MFA through single sign-on through Summit 2 authentication as well.
YubiKey support would be a really nice add there. Yeah, given the nature of these devices.
YubiKey, yeah. Physical.
Yeah. So FIDO 2 and the new ones. Yeah. We are currently working on something like Google Authenticator as well. That is coming up. That is probably going to be the next one which we're going to implement. We already know it works. It's actually relatively easy to set up. We just need to expose the configuration. Yeah. So security is actually quite important to us, and Karush alluded to it. Because yes, you're totally right. If you put everything into more or less in one basket, right, then that basket becomes you are becoming afraid that it might break because it's a perfect attack vector to get into your environment. And we take security extremely serious from ourselves, but we are not forcing you necessarily to trust us fully either. because of all the capabilities which we have to run virtual machines, to run Docker apps and all that stuff, is we have multiple customers who deploy additional security means on top of our appliance. Let it be in form of next-gen firewall, let it be in form of security and vulnerability scans or anything like it. We are, for example, fully certified with CyberArk now. So if you go to the I'm not sure if you are familiar with CyberArk, but they do access and control. They record sessions, which user gets access to what and all that stuff. So we're certified with them as well.
So that was your EDR integration, CyberArk?
Yes, correct.
Okay.
Correct. Yeah. So if you go to the CyberArk webpage, and they are under supported vendors, we're listed. So we were tools, correct. So we had the files as the first one. Second one is probably you want to just run some basic troubleshooting tools, maybe on the box in itself. We have a couple of things in the web UI, but we have far more capabilities down on the console level. So when you log in, you have access to the shell, to a normal Linux shell, and from here you can do your standard. You can do your pings, for example. Right, you can do. We have MTR as well, which I like. It's a combination of ping and trace, for example, where you see per hop what is your current latency and all that stuff. So that is quite a nice tool to have. Then you might maybe just need a standard NS lookup if that is required, or we have as well iPerf directly on the unit if you want to do a speed test or anything like it. And beside those, we have probably 50 other tools natively available on the box.
Just being naive,
yeah.
I have a question. Why would you include Telnet as an option? Isn't that
Telnet?
Isn't that really deprecated?
Just in case.
For security alone.
Just in case.
Okay, so
I find it funny.
By default is,
but scary.
Yes, no, Telnet by default, for example, is disabled. Okay, but my Rec PDU, for example, doesn't support SSH. It only supports Telnet, and the reality is, specifically if you go into the OT space, that equipment has a tendency to stick around.
But wouldn't you want to like substantiate a Docker instance, a container that can provide that at will and shut it down? And then you have a section to sell that into something instead of having it built into the box. Just curious.
So I don't know if exactly you're asking this question, but we are that segmentation box between the devices that you could say potentially doesn't support advanced security. Let's say it's just Telnet. So in fact, one of the features of the box is that we are the only device that's connected to that less secure protocol. There's no other way to Telnet to that box. And then we provide the security such that if you want to SSH to us and then we bridge it to Telnet, that's what happens on our box. Just because you want to be able to get to that thing doesn't have anything more than Telnet. You don't want it to be exposed to other devices. And we become that segmentation firewall, if you will, between an insecure device and a secure device.
Okay.
Yeah. So from our end, you can be very, very specific to which device you want to use Telnet. And as I mentioned, by default, it's not even enabled. You would never be able to Telnet to our box. We don't allow it in the first place. And to end devices, it's very, very specific to specific end devices.
Whitelisting, yeah.
Yeah, you need to actively enable it to make it actually work. Right? And as I mentioned, unfortunately, there's still equipment out there which needs it. But to your point, yes, you could easily deploy a Docker app which contains Telnet and then use that as well. Because that is exactly then my next point. What I did here as a use case, or as if you go to applications, you can deploy Docker. I mentioned that already a little bit before, so we're going to look at that in a second. But here on the virtual machines, I have a small virtual machine installed. Kali Linux in this case. So when you get full access to the Kali Linux system, just needs to boot up, and then you could just jump on and you have all the security tools which are part of Kali Linux, for example, to perform a security inspection in your local network. That gives you essentially the entire range of different tools you might need in an environment. So you have this view, as well as we provided here through the access as well. You can enable for each device or for SSH or IP-based devices as well. If you, for example, have a Windows server somewhere in your network, we can enable RDP to that Windows box as well, or VNC. And the reason, again, why do we enable that feature is to provide that separation, because then you could limit the RDP session to be local only, and we would act like a terminal server. So you only need an HTML5 browser, you connect to us, you open up the web browser on our end, the web interface, and you see the RDP session as if you would be connected locally to the device. Okay. So really what we want to do, all those insecure protocols or anything like it, we want to allow them only for as long as it really is necessary. Ideally, keep them local to the local network, very, very limited, ideally even point-to-point connections between the node grid and the end device. Now we're coming to the visibility part. I need to speed up a little bit. So visibility is all about gaining insights into your environment. And it's really a combination. We already spoke about virtualization, containerizing. A lot of those visibility tools and observability tools need some form of an agent to gather information, to forward them to their analytics. That can be in form of probing agent, maybe user experience agent, but it might be in form of a Netflow, which you might want to collect, or your environmental data. Again, through the platform which we're providing, there's a lot of capabilities natively on the box to enable you to do it. Okay. So from natively on the unit, we support SNMP. If we want to pull data from us, we can pull via SNMP information from end devices like rack PDUs and sensors as well. Absolutely no problem. But we can act like a Netflow exporter as well. Natively, everything is already here on the box. You just would click on add and configure your configuration, your collector address, and then we would just forward all the network traffic to your collector. We ourselves don't do any analysis, but we are working, for example, together with Kentech, and they can consume that information, then provide the analysis, provide events, and that is, again, information you can act on through your automation tool. Besides that, as part of the virtualization, I mentioned you can easily install probes. I've Kentech agent installed here, but it could be the same thing with a ThousandEyes agent or hundreds of other Dockerized information. Or environmental systems and audits, and environmental probes and basic network probes. You can do the analysis with our own built-in tools as well. We have now cloud a feature which is called Data Lake, and you can define profiles here which define what data is going to be collected. We really make it easy with environmental sensors. You just literally need to plug them in, enable the feature, and within minutes, we are starting to collect information. You can see that here for that specific device, that is my current air temperature and humidity. I can easily go back by a week and look how that changed. And again, I can use that to drive decisions, to drive events, and automation. If you wonder what that blob is, that we had yesterday a planned power outage in our village. So the device was done.
Are those only ZPE sensors, or are they third-party sensors, or?
In general, you can, any sensor which is supported by us, we are a vendor neutral platform in general, specifically for the out of band part. We need to support this sensor from our end, and typically we would pull information via SNMP. And as soon as we do that, we are capable of then forwarding that information to our cloud platform and providing with analysis there as well.
And to make life simple, there is 9 different sensors we sell, and it's on our website. So those are plug and play ready and on our price list.
Right. So with our own, so you just plug them in, and with third party, they're working as well.
So for the third party, do you already have a list of ones that you currently support, like from APC or some of the stuff that's running into PDUs or UPS
we have
now?
We actually have a partnership. Yeah, we have actually a partnership with Schneider. If you want to add a new device, you just go to Manage Devices, and from here you have quite a long list of different target devices. So your APC would be under the APC PDU or UPS more than likely, and if not, just come to us and we can look at it and edit as well. Now to slowly but surely to the fun part, the edge native automation. So that is now finally coming to the meat of it. Everything what you've seen up until now needs to be there. Why? Because you need it to do your day-to-day troubleshooting, break-fix scenarios. Really what we want to do is we want to enable exactly the same capabilities to your automation environment as well. Now, edge native automation is slightly different from your orchestration and automation tools, which you typically have in a centralized data center deployed or in a cloud environment, by the pure fact that it runs locally in every single location. And the reason why you want to do that very likely is, number one, there are going to be events which are really need to be handled locally. Could be a power outage which you're dealing with, and you know that you're running off a UPS for the next 5 or 10 minutes. So you maybe want to move workloads around. You might want to shut servers down. You might want to there might be 5 different things you need to do on this site within the next 10 minutes to ensure that the site can come up easily whenever you are the power is restored. Alternatively, what happens if all the warnings are getting interrupted for whatever reason? I mean, we know some environmental factors are getting stronger. Storms sometimes are getting stronger. What if your entire infrastructure in an area is completely affected? Same thing here. You want to be able to act on events which are happening locally on a local basis. Second one is scale. If you have hundreds of sites, thousands of sites, the likelihood that your cloud-based controller will start to struggle is very, very high. And one way of scaling out is by distributing. A good example is Salt, which does that, for example, by natively. The entire design is around distributed automation, but you can find similar approaches from many other automation tools as well. The other one is, we mentioned it already, it's a seat of life scenario. It's essentially day 0 deployment. It's a full automated deployment of a branch location, of an edge location, where you come on site with our device. Most of our devices can run off a small UPS, which easily fits into your bag for a couple of hours. The unit boots up, connects via LTE or 5G, and then you just plug all the other devices in, and you can fully provision an entire site within a couple of minutes using the seat of life approach. And then lastly, it's a root cause analysis for troubleshooting. we have already predefined scripts maybe locally on site where you say, okay, if it's a smart hand, if it's my level 1 technician or anything like it, instead of giving him a long run book to say, okay, if it's ABC, run the following commands, you already have that abstracted into some form of a basic automation like an Ansible playbook or something like it. And that is exactly what I'm going to show you. We're going to use our FortiGate unit here. Let me first start showing you the different event triggers which we have on our device. So briefly, again, I showed you already a little bit earlier on the data log. So we capture already everything which is happening on the device. If you want to turn that into events, then you can define that on each device by just going to Manage Devices. You go to the device name, and then under logging, you can enable logging alerts. You can define your data strings here, and then if you don't do anything, then at least you get an event, but you can directly assign a script as well to it to perform a certain action. We allow you as well to turn any event into an event trigger for automation. And you just do that under auditing, events. We list out all the different events here, every single one. You just click on it and say, okay, if that event is triggered, then perform the following action. For all of these events, we are passing through some environment variables as well, so that you actually know what actually happened, maybe on what device did a certain event happen or anything like it, so that you can make more informed decisions about what needs to be done as well. So one last thing which I want to show you is you can define per device what we call custom commands. Ultimately, those are basic automation scripts, which you just assign to an end device. You need to have a small Python library around it. I'm going to show you it's literally just a wrapper about an Ansible playbook, and then you just give them command names. Now, as soon as you do that one, you can go to a device like my FortiGate, and you see the buttons up here. If I click on Get Info, it is currently a little bit slow. I'm still working on looking into improving a little bit the speed, but ultimately it logs into the device using the console port here in this specific case, retrieves information, parses the information, and then presents them back to you. I'm using the information as well to update some information which are stored here on the device, like the serial number, what is the current firmware version, and I'm actually retrieving the target device name as well. And update it here on the node grid. Just give me. We can use the same approach to any task essentially. So as you can already see, we logged into the device, and those are the information which I retrieved back. In this case, I only run system status, and then I updated the node grid. So what happened on the node grid? So as you notice the device name is currently called FG01 Ireland, but that is actually not how the device was called, because the device was only called FG0. So I automatically updated the target device name. And if you go now into the properties of the target device, you can see here I retrieved the version number, the serial number, as well as the part number. And it's just arbitrary values which I put out. In general, you can push that data anywhere you want. Then the check config, that is in the last one. Coming back to the original question from earlier on is the save config stores configuration backup locally on the node grid. With the check config, we can then compare what the current configuration is against that one. Now, I'm not using Git in the background, so you could do it far more advanced or anything like it. I'm just using basic functionality which Ansible is providing to pull the configuration, save it locally, and then compare the current version against what is stored in the file. And Ansible can give me then automatically a diff, for example. So all of these capabilities are built into the box, and they're quite easily exposed as part of the examples which we have on our webpage. So as you can see here, there's a configuration drift there I removed, for example, the ping axis from the WAN 2 interface, and I changed the description to make it a little bit more relevant to today. And that was the last building block. And then really to finish off my part of the presentation that is really what I want to stress here is, it's not about the amount of tools you have or the tools you have. It's about how you use them. As you can see on this picture quite well, is that guy could have looked over the wall probably far better with just one single ladder if he would have known how to use it properly. And it's the same thing with any other tool you might have in your environment. It's more about how you use it. It needs to be appropriately to be fully effective.